Introduction to Drug Development, a brief history of early modern drug discovery. There are many ways to approach the history of drug development. We'll start with the invention of the light microscope in the 1600s, generally attributed to Leeuwenhoek, a textile merchant. However, Hooke, Huygens, and many others contributed, perhaps even Galileo. Then in 1777, Friedrich decides he's going to stain cells so that they show up better under microscopes. Then in 1856, Perkins develops the use of synthetic organic chemistry to produce dyes for cloth, thus another textile connection. Around 1869, Hoffman decides to use various synthetic dyes to stain cells before putting them under a light microscope. In the 1870s, Weigert uses what we now call a microtome to slice tissues into very thin sections before staining. All this prior work sets the stage, we might say, for the Pablo Picasso or the Jimi Hendrix of drug development, Paul Ehrlich. Here is the first rock star of drug development, Paul Ehrlich, oder auf Deutsch vielleicht Ehrlich, in his office. Two of the important pathogens that Ehrlich worked on over his career were Plasmodia, which causes malaria, and trypanosomes, which cause sleeping sickness. Now we'll try to summarize more than a decade of research by Ehrlich into just a couple of slides. In the late 1870s, Ehrlich wanted to try to understand the physiological mechanisms of staining as part of his PhD. He noticed that methylene blue stains nerve fibers. By 1885, Ehrlich was injecting stains into living animals, not just post-mortem. This so-called vital staining he felt would increase the quality of stains and allow him to better understand the physiological mechanisms associated with staining. As a direct result of this work, Ehrlich noticed that dyes with sulfonic acid side chains enter the brain, that is, they cross the blood-brain barrier. He also noticed that methylene blue would reduce the amount of plasmodium in vitro, that is, in laboratory cultures. In 1891, Ehrlich decided to inject patients who already had mild cases of malaria with methylene blue based on these results, and was able to cure 2 patients. So in summary, Ehrlich attempted to understand the physiological mechanisms of certain stains. He noticed that a certain organic dye invaded the area that was attacked by plasmodium. He also noticed the same dye tended to kill plasmodium in culture, and so he used that dye as a medicine in humans, curing some. Thus, Ehrlich invented the process of modern drug discovery. If you wish to consider the ethics of this process, it is important to remember that toxicological studies and their concomitant statistical analyses had yet to be invented. The situation was somewhat homologous to HIV/AIDS in the 1980s and 1990s 100 years later. In both instances, the morbidity and mortality were devastating, and so people were desperate for cures. Thus, riskier measures seemed called for. You may decide for yourself if Ehrlich's procedures were justified. On to Ehrlich's work with trypanosomes, which cause sleeping sickness. In the early 1900s, Ehrlich tried over 100 compounds in mice injected with trypanosomes and found the somewhat effective compound Nagana red. At this time, Ehrlich also tested 50 derivatives of trypan red from Casella Dye Works in what we might call a structural activity relationship study, or at least an early form of a SAR. By 1907, Ehrlich had a production deal with Casella Dye Works to produce an organic dye as a medicine for trypanosomes. He did not use the azo dye maker Bayer that had been the source of many of his other organic compounds. The company Bayer is also known today by many people as Bayer Pharmaceutical Company. So by 1907, we have a full drug development pipeline, including the modern coupling of medical research and a pharmaceutical company. Also present at this very earliest stage of modern drug development were those 2 ubiquitous features: intellectual property disputes and contract disagreements. Here are just 4 of the large number of compounds considered to treat trypanosomes in the early 1900s. There are many wonderful things to say about these compounds and their derivatives, but there simply isn't time for it here. For example, Trypan blue was considered useful in farm animals, but not in humans, because it would stain the skin blue. I presume suramin has a color somewhere in the infrared and thus can't be seen by humans. It would be interesting to know if there's a very short compound that might have an ultraviolet color, which could be useful in humans. And it would also be interesting to see a person treated with one of these drugs in a nightclub with ultraviolet lights. However, the potential toxicity of such a short-chain organic molecule would probably prevent its usefulness as a medicine. Note that the trypan blue shown here is more or less the same molecule still used today in biology labs around the world to count cells in the dye exclusion process. People thought so highly of Paul Ehrlich for producing the modern drug discovery process and for the medicines for those devastating diseases that he helped discover that the Germans put him on their money.